Hello, my name is Belise KANZIGA and I'm going to take you through my statistical machine learning assignment. I have three tasks. Task 1 is about heart disease prediction using statistical machine learning. Task 2 is about KNN classifier. And the last task is about ultra high dimensional dataset. The first task, I have a 9 wheel. The first one is about clear problem choice. The problem is about to predict whether patient has heart disease or not heart disease. I used a prevalent heart disease dataset from UCI repository and I tried the EDA. I found that there is no multicollinearity in my dataset and I found that there is no linear pattern among age and maximum heart rate. And I found that the heart disease is in male than female. About wheel 3, I found that I'm going to use logistic regression. The outcome is binary and the linear predictor provide interpretable log odds and odds ratio which are crucial for clinical setting. About wheel 4, the model can use empirical risk minimization principle where we can minimize logistic loss with empirical risk, this learning principle and evaluation criteria align with both sound statistical practice and clinical relevance. In Wheel 5, we can use iterative reweighted least square and gradient descent as standard algorithm. This algorithm choice provide efficient, reliable, and scalable training for logistic regression. In Wheel 6, the regression is going to penalize the logistic regression with ridge and lasso. This regression can refine the logistic regression model that improve robustness, interpretability, and predictive performance. In Wheel 7, we can include other models like random forest classifier to compare predictive performance against the logistic regression on the same test set. And this will ensure the logistic regression to fare against more flexible method in completing the evaluation loop. In Wheel 9, we can find the clinical features which is significantly affect heart disease risk by confidence interval, p-value, odds ratio, and standard error. And after we can deploy our model for real-world use. The second task is about KNN classifier. We tried 1NN and 27NN. We found that 1NN is better using confusion matrix. And also using LOC curve, we found that 1NN is better than 27NN. So to choose the K nearest neighbor, it can help you to know which is going to perform better. Even I found that there is false positive in 1NN and there is no false negative in 1NN. About the last task, I found that I have 6 dataset. I found 3 of them, leukemia, prostate, and colon, has ultra high dimension dataset, and this can cause that can make challenging in analyze and challenge to know which is the nearest neighbor which is better than others. About the graph, I tried 6 dataset each graph, appropriate graph on each dataset. I found that there is skewness in dataset and the dataset is discrete, continuous. This can require processing before applying machine learning models. And in heatmap, I found that the prostate dataset is the one which have high mitochondriality other than the dataset. Thank you.